Hi. Thank you. Hi, welcome everyone. Thanks for having us here in this wonderful venue. There's plenty of imaging going on this presentation, so there's no colors connected, so things might be a bit wonky at sometimes. So please understand.
Bear with us.
So my name is Jaume Sanchez. I work as a technical director and creative technologist at BeReal.
And my name is Ricardo Cabello, and as you can see, I'm not very sure which is my title. So this talk is going to be about WebGL, about what it means for the web, and how it changes the web. So WebGL is an API, like a JavaScript API, that allows us to utilize a chip on your computer that deals with the graphics on your screen. Like we usually have the CPU and the GPU. The CPU is the one that we've been able to use since all the time from JavaScript from the web. But since 2011, we are now able to access this chip from JavaScript. At the time that WebGL came out, Adobe was working on Stage 3D. Stage 3D is their own technology that also accesses the GPU, accesses this chip to display all those 3D graphics, accelerated 3D graphics. The thing was Adobe was at the time was spending a lot of resources, a lot of money on getting people to do demonstrations for the technology. So it happened at this time that people started to think that Stage 3D was so much better than WebGL, and that was a problem because, for people that, for us, that we knew about the technology, we know that at the end of the day, it's the same thing. It's using OpenGL underneath, it's using the same GPU. But people that don't know the technology is going to be oh, you have a 3D car, reflections. It's amazing. But with WebGL, you can have a cube. So it was a problem at the time, and there was not that many. I don't know if it's going to work. Yeah, there's not that many. There was no one behind the technology itself, like WebGL. Mozilla did some demos for it, but then on May 2011, I was working with Google on doing a demonstration of the technology. That it was this website. It was ROM. You can see a little bit. Preview of it.
Sorry.
Touched the walls of the city streets and didn't explain. Sadly showed us our ways of never asking why. Cast down, it was heaven sent, and to the church, no intent to repent. On my knees, just to cry. Until you travel to that place you can.
So for promoting the technology, we decided to create a music video. We thought what it would be to make a online music video that was also interactive, and also what it meant that it was also on the web, meaning that how do you integrate with users that can contribute to it. For instance, in the last scene of the music video, there is a desert scene that there are some sculptures. Those sculptures were dynamically generated by, not dynamically, but generated by users. There was a tool at the end that people a voxel, kind of like Minecraft kind of tool. So constructing all those structures. And the thing of creating this experience also was difficult because by the time that we were creating this, there were no tools. We had to create everything pretty much from scratch. There was no way There was no helpers. There was no library to like help with any of this. Like there was no, like we could reuse many of the technology that we have seen from like native applications for like OpenGL, but like we had to like create all the like animals, animations, systems, and everything. All the like player, what it's called, we had to create everything from scratch. And also, my background, like I come from like also creating like advertising campaigns for like, you know, Dolce & Gabbana and like Jaume and stuff like that. And you know that you spend like many months working on those experiences, and you are never able to contribute back to all the other developers. Like you spend like many months, but all that code is like you cannot share it with anyone else. So for us it was like or at least for me it was like a very it made me very happy that all this code that we did, we were able to like make it open source to show other people like how can they create an experience like this. It probably was not the most beautiful code, but it could have been much worse. And during that development, we also hit a point that we had to discuss what tools to use. So we had some people will like so we had like people doing the modeling, and also you needed to have like at some part of the process you need to have to combine all the like cities and to combine all everything together into one kind of like set. And to combine that, like that's just the compositing of the 3D scene. And in order to do that, you also need to also need to export that for WebGL. So for doing that, like people were like, part of the team was suggesting to use Unity. And some other people, the open source kind of like Linux radicals like me, were like really like, no, we don't have to use Unity. Like we have a chance now to create like a rich media experience without relying like showing that you can create all this stuff without having to pay for proprietary software. So in the end, we like fight a lot, and we decided to go and wrote an exporter for Blender and support Blender. Instead of having to rely on like, telling people like, you can do a WebGL experience as long as you pay for Unity, or like, you do an open source, like you can do like a WebGL experience and you can just download Blender. And so now I'm gonna like show a little bit like, show how WebGL, or how you can kind of build like WebGL a little bit. So say that we want to create a cube like this. And in order to create a cube like this, we need what's called geometry buffers. And a geometry buffer, or like what's called buffer. So in a buffer, you define the geometry like point by point. So every vertex, all those numbers like define the position of every vertex. I'm sure you're understanding all this very well. I don't. And we having all this data, then you send it to the GPU. And on the GPU, we have like two programs. One is what's called the vertex shader. Another program is the fragment shader. The vertex shader pretty much like modifies all the vertices. So if we have like one triangle here, like it's gonna, and the camera is here, then it's gonna move the vertices. And then whenever that's in position, then we have like a fragment shader that runs for all the pixels that are inside that triangle, and then like you define the color it's gonna have, like it's a texture or something like that. So of course, like, and then with all this, then we have one cube. So, like with all these, obviously you can like how you create like an experience like we did with ROM, with like having to deal with like, like this, I don't know, this horse, like the vertex is here, and then this color is gonna be here. So of course you always need like to, at the end you like need to build like a layer on top of that so it's much more simpler to like how to deal with all like that, like takes care of all this stuff for you. So at the time I was building this 3D library for JavaScript, and at the beginning it was like Canvas. I think I started it for like a previous experience that was called like the Wilderness Downtown. For the time I was working on ROM, then we started developing a lot the WebGL render. And for doing the same thing, like for just writing a cube, or for you having a cube on the screen, you have like something that is a little more like semantic, I guess, or like more like literal, something like that. And so you have like the geometry, you define so it's more like understanding geometry, understanding the material of it, and then just combining everything and just rendering into the screen. And now like Jaume is going to like talk about some of the projects that he's been building since that.
Yes, we're going to go a bit back. On April 2012, we released the Google Maps Cube game. It was based on this physical cube that showed kind of physical maps. And we turned it into a game, this kind of labyrinth marble game that you can interact with your browser, move the marble around, and reach different goals on different levels. And it was a showcase of what the new features of Google Maps were going to be at the time, like Google Indoors and Google Maps Indoors and all that. So this is the game. This was working on a WebGL browser. Back at the time, it was basically Chrome and Firefox. There wasn't anything else. And it was interesting to develop when there wasn't that many tools. So the basis for all this project started with Maya. Our 3D artists would create these cubes, these different maps, iterate across the different ideas of maybe Paris could be the level with the bike lanes, or Vegas could be the more complicated level. And this would be exported into .obj format and loaded into Three.js with a converter. Back in the day, there weren't that many tools, that many exporters, that many converters, so everything had to be like a very manual process. And all the textures, there weren't actually textures, everything were vertex colors, so it was painted on the triangles. And this, for instance, this is an example of the final stage of the process, when there's the geometry and you can see the paths, and actually there's hidden geometries for collision meshes, so the ball can bounce off different geometries. So the workflow for this project was we had our in-house 3D artist building all the levels, refining them with the art director and designers, export to Maya, and then we would just take it, convert it to JavaScript files, run it directly into the game. So you had to go into, I don't know, if it's the 6th level, you had to go into the 6th level, play the 6th level, and identify problems, optimize, and then iterate on that, and then show it to the client. 1 year later, in September 2013, we were working on this project codenamed Wind and Sun. It involved a lot of cows, also pigs, and camping tents, but mostly cows. It was an experience going through the different stories of the wind and the sun across an enormous landscape, a low polygon landscape, and you would go flying by and see how things interact with nature. You had plenty of different models of trees, lighthouses. The landscape was constructed of these chunks that would be loaded across hundreds of these pieces. Lots of detail meshes, and overall like a very nice feeling to it, like vertex coloring. And one thing that we did is these white triangles are actually position meshes. So in order for the designers to place hundreds of thousands of trees and make the download, the load of the site reasonably fast, there was like 6 references for each different tree, 6 variations of a birch or a pine tree. And this would be the kind of location mesh. We would replace each triangle for a variation of one of the trees, and everything would be compiled, uploaded to the GPU, and then rendered. This is a preview. This is a capture from the preview tool, in which you can see how we were analyzing everything, how everything looked, make sure that all the angles were right. And so basically the workflow, as I said, we had a 3D vendor that would create, with Max and Maya, would create this landscape and the detail meshes. And this is an example of how it looks with the landscape, houses. You can still see the triangles that would be bushes and flowers and everything. This is an overview, like a raw preview of where all the trees are already in place, no shadows nor anything. So they would be creating these chunks of terrain, all the objects like trees, cacti, all kind of vegetation, rocks, The detailed meshes would be like a house or the lighthouse or a chicken. Everything would be exported directly into Collada, and then by the time we were already able to load Collada files, and we would load it into our system. So our 3D artist would check that everything was right, that there was no mysteries. That's the CSI part, like why suddenly all the meshes are 100 times bigger, or why is everything on the infinity. So he would identify what was wrong with the models and create pre-visualizations for everyone to understand what we were trying to build. This was our pre-visualization tool. This is when all the different models would be turned into binary, which means that as opposite to the previous example with Google Maps Cube, that the models would be downloaded from the server in a JavaScript format, processed on the browser, and then converted into buffers and uploaded to the GPU. What we did is turn those geometries directly into buffers, and from the server would be downloaded almost right into the GPU. So there would be no overhead, it would be way faster and more lightweight. And in order for the artist to not have to place everything on the terrain, the shadows would also be generated and placed on the terrain. Post-process would be added, and all kind of physics and animations. This is an example of the tree generation placing on the geometry, and an example of how it looked like a specific slice of terrain would look towards the end. So, augmenting the previous loop with the 3D artist, we would have our WebGL preview tool. We would preview everything, identify problems, optimize, and like removing everything that wasn't needed, and then output to binary. And then we would have our proper WebGL engine with the experience. So we have two loops for iterating and making everything smooth and performant. This was actually the first experience that ran on our Nexus 4. And if you're wondering why you haven't seen it, it's because it got canceled. But right at the same time, we were developing the Gravity website for Alfonso Cuarón movie, and most of the technology for Wind and Sun got right ported into the Gravity project. I guess you've already seen this project. It's basically an online experience using WebGL and to reproduce the situation of the movie in which you're floating on space. It's got missing textures, but it's got immersive sound, 3D sound.
Mission abort. Repeat. Mission abort.
So the challenge for this project was kind of the same goal as the previous one, as Wind and Sun. It was a lightweight, trying to get a lightweight download and easy on the browser. But as opposite to Wind and Sun that we started from scratch and created all the models, in Gravity we had to start with the I don't know where we are. We had to start with the assets from the movie. So we work with Framestore. And they just sent us the original assets that they used for the movie. So that was like hundreds of millions of triangles and several textures of 8K weighing like several hundreds gigabytes. It was crazy. Our machines couldn't even load any of the models. So we had to create a process to reduce the polygonalization. I guess you can see on the right that there's more than on the left, so simplifying without removing a lot of detail. Also keeping enough details for the shaders to really look like the cinematic experience. And this is a video of the original mesh, and after being cleared and reduced to a few 100,000 polygons, which was something that at the time the browsers could handle. In this case, the workflow is kind of similar. There's no iteration with the vendor. They just sent us the details, so we have to get our in-house 3D artist to simplify the meshes, use baked colors for the low poly models, the ones that are far away, and baked textures with color and lighting for the close-up models. And same thing, we would have our WebGL preview tool to make sure that everything looked nice, everything was performant. We could tinker with the shaders in that tool, make sure that everything was set, and then use our WebGL engine experience proper to do the camera editing, to do the post-processing, integrate the UX and UI, and create the experience. And
Okay, so
yeah,
so WebVR, it's another like new API. It's kind of, I think it started like about like some months ago. As you're probably aware, like this VR thing, like Oculus Rift and things like that, is kind of like pretty, kind of like on the news all the time lately. So, and it's been always something that you can only play with it if you are like doing like a like native application. But some people at Mozilla and some people at Google, they started working on this new API that to allow us to access like Oculus Rift devices, or like not even Oculus, not only Oculus devices. Like they're defining it in a way that you can also like have like a cardboard device. Like you don't know what a cardboard device is. It's like just a piece of cardboard that like just comes like in a packet like this that then you can assemble yourself, and then you put your phone in it. And that pretty much emulates the same as an Oculus Rift. It's like something like $10 compared to like $400. But it kind of does a pretty good trick. So the Mozilla people started this specification of this like new API. Oh, you don't remember the one? You don't say. Well, oh, must be R. Oh, it's not going to load?
anyone has the password for the wireless?
No one?
Anyone? Sorry, keep talking.
Auditori.
¿Cómo?
996? 96.
96?
So with Mozilla, they also wanted to do a website that will kind of like start to show the kind of things that you can do with this, kind of demonstrate like what does it mean that you can like have like virtual reality in the browser. So they did this website, and I helped them doing. This is upside down. Okay. I just helped them building like some basic. Like at the end of the day, like WebVR, like obviously benefits a lot for something like WebGL. Like you want to create these real-time 3D environments that you can also like you need to be able to update depending on where the position of the head is. So again, they don't want to like build the whole thing from WebGL from scratch. So I just help them a little bit like building some like tools on top of Three.js, so you can do like a WebVR like VR experiences like very easily. This one was pretty basic, but it just helped them. Like they didn't really have that much experience on real-time 3D, so it was a good starter to kind of like show how it works. So actually, the way it works is this is all like Firefox nightly, and like also some like builds of a Chrome. Like this is not really unstable, but the way it works is like you just set up, you render the whole like scene in 2 views, like one for each eye. And then the browser is going to do the distortion depending on the device. The browser takes care of the device for you. So also, Jaume did
Yeah, so it's actually pretty easy. Sorry, 1 second. So to take one experience that you already have and reuse the assets for creating a virtual reality experience. So for this event in New York, the Future of Storytelling, we created this experience using the exact same assets that you've seen.
And so now you can be Sandra Bullock yourself.
Yeah, basically, you can stay in the path of the debris and everything. So everything is running on the browser. Just connect an Oculus or a cardboard, and it's very performant.
Cool.
No.
So this is all pretty experimental. Like this still like just works on some specific versions of the browser, but hopefully by the end of this year, like things are start to land stable, and it's gonna be like pretty fun to play with all this stuff. Just kind of a funny anecdote about this is like the landscape VR demo that I helped Mozilla people. The guy that was doing the models, he pretty much like knew only Cinema 4D. So we needed to find a way to for him to create the world, and also he wanted to be able to create the path of where the camera is going to be. And so how do you export? How do you get that data from Cinema 4D out to the WebGL? So we found out that whenever you will click on if you click on the line, there is a panel on the right on I think it was structure that gives you all those numbers. All those numbers is what I care about. But how do you export them from there? How can I export them so I can load them? I can just do a player of that curve myself. So it turns out that it is you can export that panel has a export ASCII panel. So I don't have Cinema 4D myself, and I was using the demo version to be able to get this data that he was providing me for that. And as soon as I click on export ASCII data, it will tell me that I need to buy a license, or tell me that I need to buy the program. Well, it turns out that the program is about $1,000, and I only needed to export one curve, and I had to pay for that, only for exporting maybe one or twice. So next time you don't, you say Blender is very complicated, just think about this.
So we're getting close to nowadays. On June 2014, we released the Smartwater website. This one already runs on every device. It got already on the mobile first concept of web developing. So it works on tablets, it works on mobile phones, it works on desktop. If you haven't seen it, it's basically it's an immersive experience with reactive sound. The good thing of this site as an example is that you don't actually have to think of 3D, 3D triangles, meshes, and things that go 3D and low poly. You can actually still use WebGL to create compelling visuals with just, in this case, for instance, this is just flat surfaces that are looking towards the camera with a cloud texture, and they have nothing like what we've been talking about 3D. With this project, we already had something of a problem that we've been having with all the different projects, which is how to tell the user how to interact. What's the way of driving the user interaction when these things are not very familiar? This comes from the times of Flash, but we've been trying to find different approaches. In this case, for instance, you could find different activities to explore, and this would be CSS. This would be your traditional CSS animation with spreadsheet, but then it would be integrated into something that allows you to create 3D sound and 3D clouds. And you can still kind of start creating a 2D web page, a traditional 2D web page, but there's a component that you can drive with JavaScript that gives you this. And so this same thing, you can kind of rotate and create sound. This was using Three.js as the engine for 3D computations, and the drawing was actually performed by Pixie.js, so it uses Canvas or WebGL depending on the platform features. So finally, this year, this is more like a personal project. This is trying to see how far can we get into 3D imagery, realism. How can we? How many cool graphics can we put on the browser? So. We actually had to add an interactive mode because people wouldn't believe that this is actually 3D and not a video. So in order to show that everything is being rendered in real time and it works on the browser. So that's a nice compliment when they tell you that, man, it looks like a video. Actually, it looks better than a video. Thank you. At least it weighs less than the equivalent of a video.
Okay, so I think it was about 2 years ago already. I started realizing that all these stuff was like very great. It's all like pretty cool like toys for like developers, but like the designers and the artists were like kind of left aside. It was very difficult for them to play with this technology. And as someone was mentioning yesterday, don't take out Flash on me. So like we needed to have like some like tools to, I should like delete this stuff, for like also, so like people that want to like either help a developer or like even create their own things themselves, they need to have also to have some tools to play with this to iterate quicker. So I started building this editor, which also runs inside the browser. It's like part of the Three.js repository. You can play with it if you want. More like, I wasn't really sure at the beginning what it was for, but then at some point I started building a game myself for another project. And for that, I really wanted to have like a tool, like an editor for creating the levels without having to like be on Blender and exporting. I could just like create the levels myself. So here you can like kind of like create a little bit of the basics of it. Like you can think of it as a very like basic like internet 3D Studio Max or like a very super basic like Unity kind of thing. But the good thing of this, like in the same way as Unity, the good thing of this kind of like environment is that what you see there is running on 3. So what you see there is exactly how it's going to look like. So from here, you can like imagine like being, let's see, I'm going to like some simple, I don't know if this is, okay. Some more stuff. This is not very effective. From here, you can like kind of like see how the whole thing is going to look, and at the same time, you can like work with the developer. The developer, you don't need to tell the developer like, oh, can you move this one to the left? Can you move this one to the right? Or like put this like here or yada yada. From here, you can also, it also turns out to be like very useful also as a teaching kind of like the API itself, because it shows kind of all the parameters that every geometry has internally, and you can like kind of see like, okay, so like, so you have the scene, and then you have like the mesh and the geometry and material. You can kind of like do a visualization of the API itself. So at the beginning, so I had it like this, and then from here, like the guy called like, you can also like load here your OBJ files and like all the textures and everything. Like, sadly, I don't have them many at this point. Like, actually, this talking about the editor requires like an hour at least. But like as a kind of preview, like this helps. And so from here, you can export the data, like a JSON file that is what the developer wants. So it's much easier to work with all the people. And at the same time, while I had this, this is probably not the best looking object here. While I had this, I thought that maybe it will be like a nice idea to try to also add some scripting to it. Like it wouldn't like really take me too much time to like try to implement it. Like I had the editor myself. Or I had the editor already built. So about like some months ago, I started working on this thing. So you can select any object on your scene, and you can add like a script to it. You can think of it as a behavior or something like that. And then inside here, you have like a script, like in the same like how it used to be like with Flash. So you have like some method, you have like update or like mouse move or like mouse out and like things like that. So say that here you can just add like some very basic. So for instance, we're going to make that every Spanish keyboard. You're going to make that every frame that we render, I don't know if you can see it, the torus, or this thing looking like a torus, is going to spin a tiny bit. And you can like, if you, oh wow. I guess it's a demo, doesn't work those things. Nope. So the play doesn't work. Maybe the publish works? No, it's not. So whenever you click on play, for whatever reason, the whole like preview becomes like animated. It's something with the projector, I think. But you can also publish it, and let's see if this works. Nope. Well, I don't know. You have to trust me. This works when it's not with the Oculus, and that was the part that wasn't probably going to work. Maybe if I get rid of this. That still works. No, it's okay. Anyway, so you should play with it yourself a little bit. It's actually pretty fun. You can just publish from there and just try see how the whole thing works without really having to deal with any developer yourself, which is I know is very it's something you really want to do. But yeah, this is pretty much what we've been working on over the last 5 years now, and hopefully you can hopefully help you to play with it.